Business continuity planning is integral to the availability of systems, and, as stated earlier, availability is part of the CIA triad. It should therefore go without saying that in order to enhance business continuity for an organization, availability controls should be implemented. One way IT professionals do this is through the use of redundant systems. In IT, the term redundant can refer to various situations. The term redundant can describe computer or network system components, such as fans, hard disk drives, servers, operating systems, switches, and telecommunication links that are to back up primary resources in case they fail. Redundancy is commonly built into the network at a routing protocol level. They are configured so if one link goes down or gets congested, then traffic is routed over a different network link. Another business continuity control would be single point of failure, or SPOF. A single point of failure is a part of a system that, if it fails, will stop the entire system from working. Single point of failures are undesirable in any system. A single point of failure poses a lot of potential risk to a network because if the device fails, a segment or even the entire network is negatively affected. Some of the hardware devices that present single point of failure vulnerabilities are firewalls, routers, network access servers, switches, bridges, hubs, and authentication servers. The best defense for a single point of failure is maintenance, regular backups, redundancy, and fault tolerance. There are two key technical concepts that improve the availability of systems. High availability, otherwise known as HA, is one of them. High availability is the concept or goal of ensuring your critical systems are always functioning. In practice, this means creating and managing the ability to automatically fail over to a secondary system if the system goes down for any reason, as well as eliminating all single points of failure from your infrastructure. High availability is a strategy that requires careful planning and the use of tools. Having a well thought out high availability architecture is important because the cost of downtime is high, whether we're talking about dollar figures, the loss of staff productivity, or the life of a patient who becomes vulnerable to risk the very moment the hospital system goes down. The other key technical concept is fault tolerance. Fault tolerance describes a computer system or technology infrastructure that is designed in such a way that when one component fails, be it hardware or software, a backup component takes over operations immediately so that there is no loss of service. The concept of having backup components in place is called redundancy, and the more backup components you have in place, the more tolerant your network is of hardware and software failure. For example, a single application running at the same time on two servers. The servers essentially mirror each other, so that when an instruction is executed on the primary server, it is also executed on the secondary server. If the primary server crashes or loses power, the secondary server takes over with zero downtime. There are two small drawbacks of fault tolerance, however. It is more costly because both servers are running all the time, and there is a risk of both servers going down if there's a problem with the operating system that the servers are using. As a security professional, once you've had a better understanding of the significance of the terms of high availability and fault tolerance, the next step would be to evaluate your current backup plan. Is your disaster recovery plan thorough enough? Are failover options a part of your high availability architecture? How tolerant are your networks to failure? The answers to these questions will determine how prepared your organization is for when the unexpected happens.